about dual radio mode means what's happening over there. For example, we have two different nodes and we need to make them communication. Means, for example, if we want to make a sensoring system in our home and we have two different microcontrollers or two same microcontrollers even though, means two node MCUs, and we have a radio module, and right now we want to share the data from one node MCU to another node MCU. So on that time, we are going to do this. Means right now the TXRX has been established so that they are going to exchange their information and data. All right, I think participants are joined right now. Let's go with the topic. Which sensor can use to detect only a living thing? Living thing, living thing. Okay. If we want to detect a living thing, so on that time, of course, we can use yeah, no, infrared sensor, because every living organism produce some kind of thermal effect that we can detect easily, and in general way, and by the thermal imaging we can detect what kind of shape we are going to see from the thermal imaging, and we can process the image through the AI, and by this we can tell what kind of living organism is it. Is it an animal, or is it a human being? If it is appear like a human structure, so we can say that yes, this is a human being. So by the help of these things we can do that. So let's start the session. And in last session we were discussing about the right now we were discussing about what? ESC. Okay, we were starting the point of ESC, and we were discuss about, good evening everyone. So we were discussing about the BLDC motor. Okay, so I hope you got the point that how the VLDC motor works. Technically, before I'm going to start this session, I need to tell you one more thing. Everyone wants to stay and study in the comfort zone. Means the field and the criteria that we know about, or the topic which we already learned. Most of the time, we try to stick with it because that's the comfort zone for us. So the thing is that if we don't, or don't break the comfort zone, or if we don't gonna work way beyond from the comfort zone, what will happen on that time? We couldn't get something new, or we couldn't get some innovative points. So right now we are going to do this. We are crossing some comfort zones right now, because we are going to talk about some deep electronics, as well as some deep technology points we are going to talk about. So please be prepared that today's session is going to be a little bit shaky, because there are lots of information I need to deliver for you. Okay, so let's begin the session. And first of all, I need to give you a quick review so that we can refresh the memory that what we already learned. We were talking about the BLDC motor in last session. Okay, means we cover the point of BLDC, and we learned that how the BLDC works, what are the mechanism working behind the BLDC, what is the outer structure and inner structure of the BLDC, and then we learn about what kind of connection points we are going to get from the BLDC. That we already learned. We understand about these motors, how they are going to connect. We understand one more thing, that BLDC having 3 wires for connections, means it is going to take power from 3 wires. I already told you in BLDC the structural wiring connection is on the basis of delta connection. So right now we are going towards another point which is very important in drone family to build a drone, that is the ESC, electronic speed controller. Yes, that is the one of the most important point which we have to understand. Without understanding the electronic speed controller, we couldn't build a correct, and a proper flyable drone. Yes, that is the true point we have to understand first. Because if we are going to build a drone, it has to be that it is built by the right components. Means if the components are not going to match each other, they are not going to work properly. That is the issue we are going to face while we are going to build these kind of vehicle, these kind of machine, or these kind of project, if you want to say on your own language. So right now, first we have to understand with a very peace of mind that what is ESC and how we know that what kind of ESC we are going to use for our build. That is the point we have to understand first. So first of all, let me explain what is ESC and how it's going to work. So technically what's happening over here? If I'm talking about this ESC, this is the image of ESC flashing on the screen right now. So what we have over here, first we need to understand this. Just give me a second. I need to put these things aside because later on we are going to use those points. So let's understand about the ESC. So there we go. Right now, what we have, if I'm talking about this port or this section, okay, I hope everyone can see this part. Clear? This point and this point. That is the connector which is going to fix with the battery module. Okay, but there is a point, there is a catch. In practical implementation, we cannot use that connector. Why? I'm going to explain it later, because we need to install the PDB, because we need install multiple ESCs. Okay. If I'm talking about a battery, we have a battery over here for you. If I'm talking about a battery, this is the battery. There is lots of information that I need to deliver about the battery also. So for example, this is the XT60 connector, but in general language, we are going to talk it like a connector, just connector, okay? It's having a single port over there. But if I'm talking about 4 different motors for quadcopter, we are going to talk about 4 different motors. So on that time, we need 4 different ESCs. Yes, that is the point. We need 4 different ESCs. So on that time, we cannot use that connector to create that type of connection. We need a circuit board which is known as PDB, power distribution board. Why? I'm going to explain it later on, because we need to give power to the multiple components, including ESCs. So right now, we need to remove these connectors. Okay, we need to cut this connector, and we are going to put the wire directly to the circuit board. That is the method which we have to use by soldering method. But let's understand the point first. So this connector is used for getting the power from the battery. So it means we are going to put 11 volt, 12 volt, or what volt we are going to put over there. That is the question. How we can decide how much amount of volt we need to put over there? That is the question. So before we are going to understand this, we have to cover up of one more point, that there is a S rating in each and every ESC. What is the S rating says? S rating represents that how many cells this ESC gonna support. For example, it is going to represent as 3S. Okay, 3S means the battery which having 3 lithium polymer cell connected in series. Okay, that is 3S. Similarly, if it is a power rating with 4S, okay, So if I'm talking about a 4s cell that has to be connected, means there are 4 lithium polymer cell is going to be connect in series. That is the point which I need to tell you. So if I'm talking about 4 lithium polymer cell is going to connect in series. So technically, if I'm saying if the battery is full charge, each polymer cell is going to give us almost 4 volt, 4 volt or 4.1 volt. Okay. So on that point, if the ESC can support 4S, means the ESC can able to support up to 16 volt battery. Yes, the ESC can support up to 16 volt battery. That is the point we have to understand. Most of the case, what's happened, we couldn't understand that what specification is written over there, and without understanding the specification, we are going to put these components in our belt. Then what will happen? The component is not gonna work as per the component has to work on its that we think or we imagine that the components has to work like this. But the output from the component is not gonna be like that as per our imagining. Why? Because we couldn't match the proper specification that we want, or that the component is going to be for run properly. That is the thing. So technically, we have to understand the point that if the component want that much amount of voltage, you have to provide the ESC that much amount of voltage so that it can work on its peak. That is the thing we have to understand first. But before we are going to talk about these things, we have to understand the mechanism behind this. So let's start the mechanism of the ESC, that how the ESC is going to work and how the ESC is going to rotate that motor. Okay. So first of all, we have to understand that I already told you in last session, but I'm going to tell it again for you, that we have 6 MOSFETs. On the basis of 2 MOSFETs are going to be create their pair. So technically, we have 3 MOSFETs paired with each other. So technically, what's happening here? In this situation, we have a set of MOSFET like this. Okay. So what's happening over here? It is going to act like a tunnel which is going to open and close as per the instruction. That is the first point. So what's happening here? Each and every phase, for example, this is phase 1, this is phase 2, and this is phase 3. So what's happening? This set of MOSFET going to operate the phase number 1. Similarly, this set of MOSFET is going to operate the phase number 2, and this one is going to operate the phase number 3. Then what will happen with it? What is the point behind this? So what's happening here? If I'm talking about the motor, in this motor that I already represent over there, now we have to see that over here that we have a set of coils. First is like this, another set of coil is going to be like this, and the last one pair going to be look like this. Now what's happening over here? We are going to energize these coils by the help of the set of MOSFET. What the MOSFET is going to do for this coil? It's going to give a blast of current, and then it's going to stop. Why it is going to stop? Because now it is going to energize the another one. Then what will happen on that time? First, it is going to energize this coil, for example, the coil number 1. When it is going to energize this coil, then what will happen on that condition? The outer stator, this outer stator I'm talking about, this outer stator feel that there is a magnetic field present in my core. Then what will happen? There is a phenomenon happen which is act like a push and pull. Means, for example, if I'm talking about the magnetic field which we are going to face right now. So what's happening here, for example, this set of magnetic pair is activating right now. Then what will happen on this situation? It is going to create a magnetic field in this area and in this area. Okay. When it is going to create two different magnetic fields, and this magnet is going to get that magnetic field from the winding, it is going to push itself because it want to go away from it. And similarly, this part of the magnet is going to start pull towards this. Okay, then what will happen on that position? I'm talking about this magnet. Okay, that magnet is going to attract towards this. So then what will happen for a fraction of second? It is facing that. What's happening inside the magnetic coil, that it feel a rotating magnetic field is going to give a continuous push to the outer stator. Then what's going to happen with it? Let's understand. Just give me a second. I need to change the slide. Then this magnetic coil, this magnetic coil is going to give a continuous rotation to the motor. Okay, in very general and layman words. So that is the mechanism behind the ESCs. That how the ESC is going to work for us. But the question is that how the ESC is going to know that when it is has to increase the speed, means the frequency of changing the phase. So it's totally based on the signal is going to send from the microcontroller. Okay, right now I'm talking about this microcontroller. It's general a simple microcontroller. Okay, we are not using a flight controller right now. So what's happening over here? We give a signal to the ESC. That I already told you, ESC already contain a microcontroller inside it. That controller is going to understand the PWM signal. Okay, that PWM signal is what it's going to do for us. The PWM signal is going to change the width of that signal, and as per the width of the signal, the controller is going to change the frequency of the rotation. So technically speaking, that if the PWM signal is high, means the pulse width modulation, the width of the pulse is going to increase, then what's happening? The switching speed on the MOSFET is going to be increased so that it can very fastly energize these coils. And while they are going to energize these coils, then what will happen? The rotation of the motor has to be fast. That we have to understand right now. Then the question is that, fine, we have the motor rotation. That's okay. But the problem is that we don't want the direction in which the motor is rotating. Now we need to change the direction of the motor. That is the biggest issue right now we are going to face, because motor is rotating. Fine. The speed and the RPM we can control. That's also fine. Sorry, due to technical issue, I was unable to join. Okay. Don't worry. We are just starting the topic, so everything is okay. And Jai Hind. So, good evening, everyone. Okay. So, right now, what we are going to do, we have to understand a very crucial point, that ESC can control the speed. Okay, fine. We can give PWM signal to SC. That's also fine. But the problem is that how we can change the direction of the motor. That's the biggest issue right now we have to face. Don't worry. There are some technique that we have to understand, that how the motor is going to change its direction. Let's understand that point. How to do that? But before I am proceeding on that point, I need to tell you one more thing. For example, this motor, the image is representing on the screen, it's representing CW over there. Where? Over here. See. Over here, that point. It's representing CW. CW represents counter clock. Sorry, CW represent clockwise. If it is representing CCW, CCW means by interchanging any two phase. Any two phase, yes, by interchanging any two phase. That's true. But right now we have something more that gonna help us to, without changing the phase, we can do that. So yes, there is a technique, but the answer is definitely correct by changing the two phase. But what two phase we are going to talk about? We are going to discuss it on later. So in motors, it's representing CW or CCW. So CW means clockwise and CCW represented counterclockwise. But the problem is that, is there a specific direction for the motor? Means technically, if a motor is written on CW and by mistaken or for the sake of experiment, I just turn the motor in counterclockwise. The motor represent I'm going to work in clockwise. But what we are going to do to just check or for the experiment, we are going to rotate the motor in counterclockwise. Now the question is that what will happen? The bearing gonna damage, or the winding is going to be damaged, or the stator is not going to work. What's going to happen on that time? That is the point we have to understand. What's going to happen on that time? So now, technically, if I'm talking about that situation, what will happen? With the motor, nothing is going to be happen. Why? Because technically, BLDC motor can rotate in bidirection. There is no issue that you can rotate it counterclock or clockwise. But there is something that we have to understand. What's going to happen? If motor is okay, then what problem we are going to face if we are rotating reverse direction in the motor? Means we are going to rotate the motor in reverse direction as per the instruction. Means motor is clock and we are rotating it counterclock, or the motor is counterclock, we are rotating in clockwise. So what happened on that time? Listen up very carefully. Now we are going to talk about a very important point, which is the shaft of the motor. This is the shaft of the motor. We are going to talk about that part. Okay, so what's happening in this situation? Technically, what's happening, if I'm talking about this drone, it's having technically two pair of motor. Why? Because few wings are going to rotate in clockwise and few are going to rotate in counterclockwise. What's happening on that time? If I'm gonna interchange the motor, nothing's gonna happen with the motor, but the problem we are going to facing with the thread. Means technically, if I'm talking about counterclock, the group they created over here, the group in which the nut is going to be placed, it is designed for counterclock. Means if the motor is going to rotate in counterclock, the screw or the nut which we are going to tight at the fan blade go out. Yes, due to the nut is going to untie. Okay. On that time, what's going to happen if we use a clock motor to run in clock direction? Then what's happened? The screw which we are going to tight on the head of the shaft, it's not going to loose. That is the point we have to understand. Okay, that is the biggest issue. It's all about the thread they are going to create for the shaft. That we have to understand. It's all about the screws. That's it. It's not about the stator. It's not about the motor. It's not about anything. It's total about the shaft that we are using or the screw which we are going to tighten over there. That's it. Okay. So now the question is that how we can interchange the direction of the motor by changing the phase. That is the way traditional method, one of the best traditional method by interchanging the phase. But how we can interchange the phase? Let me explain first. So as I already told you, over here there are three different wires. Okay. So as you see, this is red at the good evening everyone. The red at the first wire, black at the middle, and yellow at the center right now in this condition. So, which we have over there, three wires, fine. And if I'm talking about the ESC, still it's having a three wire so that all the three wires of the motor is going to connect with it. All right, that's okay. Means the connection could be look like this. But if we're talking about how to interchange the direction, let's do it. So the traditional way is this. What we need to do first. First of all, if you want to make the direction clockwise of the motor, what you're going to do, you have to connect all the wires sequentially one by one directly to the ESC without any interchange. There is a trick. There is a trick while we are connecting these wires. Always remember, connect the middle wire of the motor and the middle wire of the ESC first. Okay, you need to just put the middle wires first. Why? Because so that you can decide the rotation of the motor. Okay. If you are beginning in this, means if you are a beginner in the building of these drones or these kind of gadgets, so you can do that. If you are expert, you can go with any method that you like to prefer. But first connect with the center wire. Then you have to decide the rotation, what rotation you want. For example, we want clock rotation. If we want a clock rotation, clockwise rotation, what we going to do? We are going to do just the follow the sequence and nothing. Means first has to be connect with the first. Means first wire of the motor has to connect with the first of ESC. Middle, of course, is going to be connect with the middle one, and similarly, the last one has to be connect with the last wire of ES. Means third one has to be connect with the third one. That's it. Okay. Starting with the good evening, thank you. And the thing is that if we want to interchange it, what we are going to do? Remember, do not touch the middle wire. Do not touch the middle wire. What you're going to do? You are going to change and swipe the outer two wires. Okay, means you have to connect the first one of motor with the third one to the ESC. Similarly, the third one of the motor has to be connect with the first one of the ESC. Now you can change the direction of the motor. Is there any emulator okay for running IoT device? Yes, we can use some simulator, and emulators is also available, but I think you have to purchase that. So first let me find if there any kind of free emulator is available that doesn't want any kind of purchase or subscription. I'm going to share it with you. Okay. So that is the concept we have to understand. It's done. Let's put the wire together so that we can connect the motor and the ESC together and build the setup. That's the point. Thank you. Thank you so much. Okay. So if we are going to talk about the inside of the ESC, that is the inside part of the ESC. There you saw on your screen right now. So what's happening here? You see there are 6 set of MOSFETs and paired in 2 What's happening here? It's going to energize 1, 2, and 3 phase one by one so that the motor can get its rotation. That's it, simple. So right now we cover up how we can connect the ESC, what should be the method of connection of ESC, that's it. Now we have to move forward that is there any kind of ESC that is more advanced than the traditional ESC, or the ESC that can act like a smart ESC. So right now I'm going to give you some modern information about ESC. Okay, so technically, if I'm talking about a ESC, there are few different ESCs are available in market that we have to understand first. The basic ESC that I represented over here, this one, okay, that ESC, the red one. Technically, there are two colors of ESC available. They called it red one, or another one, it appeared a yellow. Okay, that is the most common ESC that you can purchase. But what is the difference between these ESCs? Okay, now listen up. It's all about the firmware present in these ESCs. What kind of, technically in simple words I'm speaking, what software is put on these ESCs, that is the first point we have to understand. Okay, there are different firmwares present, means different versions of software present for these ESCs, and different version of software having different capabilities to do. Okay, so if I'm talking about the first ESC which we have over here, this one, this ESC is known as Shimong. Shimong is not a company. Shimong is a firmware, is a software. Okay, this is the most basic ESC that a person can buy from online and an open market. It could be cost around 500 to 600 rupees that you can purchase very easy. What are the drawbacks with the Shimong ESC? First, we have to understand. The drawback is, sorry, the Shimong ESC, where it is, the Shimong ESCs are not able to get apply brake on the BLDCs. There is no braking mechanism for the BLDC, that we have to understand. There is no braking system, first point. Second point, if we are talking about high speed switching in signals, means we want to make an acrobatic drone. That today Zoom link are not send in WhatsApp. Okay, I don't know about it because it is very much possible the team doesn't send the link. So same link work. Yes, the same link works because I already connect from the same link actually. The link is same for the 4th of the March, and then the link is going to be expired. So the link is scheduled, the time set is scheduled, everything is scheduled, because on the basis of the time schedule and date, the links work. So it's easy for us. We don't want to build new links and send new link. We can just use the previous one. All right. So right now we are going to talk about the Shimong. Okay, that's the point. But still we use Shimong because it's easy available and cheap. All right. But what if we want to make some acrobatic drones or some aggressive drone that can having a quick response, having a brake mechanism, having acrobatic movements. Acrobatic means if you want to flip the drone, if you want to make the drones upside down to fly, these kind of thing has been done by the firmware which is known as Bell Hell. Okay, just make it front for you. There it is. This is known as Bell Hell firmware. Okay. So what is this firmware and what is the capability of these ESCs? First of all, listen up very carefully. while we are making a drone, technically we are making a vehicle right now. Okay, the vehicle that can fly. All right, a vehicle that can fly. Fine. So if we are talking about avionics, on that point we have to consider the weight. If the weight is going to be increased, then what will happen? The battery timing is going to be reduced. Then the flight, if the battery timing is going to reduce, the flight timing is going to reduce as well. As then what will happen? The motor is working on overload. You need to make it more bulky, as well as we have to face multiple issues: heating effect, draining battery. You have to charge the battery frequently, so it is going to degrade the cell. Even though, so on that time we have to understand that we need a light setup. Light setup means a ESC that doesn't have a huge weight that gonna create some problem for us. Means if I'm talking about the traditional ESC, this one is a huge size ESC and having a lots of weight. And the point is that if we are building a simplest drone, it is going to be a quadcopter, means four motors. For four motors, we are going to put four different Shimong ESCs. And if we are going to put four different Shimong ESCs, then what will happen? On that time, we have to understand the thing that if we are using four different ESCs, it is going to increase the weight of that. That is the biggest issue we are going to face over there. So to overcome that, we need to upgrade these ESCs. And how we can do that? Let's understand the point. By the Bell Hell ESCs, we have to, sorry, where it is there. So while we are going to use the Bell Hell ESC, what we have over here, we have a compact, small circuitry, and the biggest point, means the biggest achievement in Bell Hell, they are not gonna heat as compared to the Shimong. Shimong generates a humongous amount of heat. They having the MOSFET that produce a large amount of heat while they are flying. Okay, so that is the point. In Bell Hell, there are different, you can say, different models are available. Model means there are different versions of Bell Hell is available: Octo Shot, D Shot, and One Shot. These are the different type of ESCs, but we are not going to discuss it right now because the session is going to be very lengthy if I'm going to that direction. Because D shot is having a blast of current in it, means you can put a big and large amount of current blast in it. It's gonna handle that very easily. So there are some different characteristics in these ESCs. So that is the firmware I want to show you. And now the final one, this one, who is it and how this is gonna work. So let me zoom this for you. Why it is behind the ESC. Let me bring it front first. This is known as all-in-one ESC. Now what is all-in-one? So technically, if I'm gonna build a compact drone or a micro drone, on that time, the space we have almost negligible. We have to put the flight controller, we have to put the battery, we have to put the PDB over there. PDB means power distribution board. So everything we have to put over there means we are going to create a stack. So while we are going to build a stack, we need a compact ESCs. So what's happening here, this is one of the most advanced ESC. Okay. And one more thing that I need to tell, that Bell Hell can reverse the direction of the motor also. Okay, that is one more point we have to understand. So right now, what's happening over here? We have set of connections over here. This is a first set of connection. For the yeah, you can say this is the first set. The circle I made, it's quite large. Second set, third set and fourth set right now. Okay, so technically it's having 4 different connecting points, each connecting point having 3 set of connectors. Okay, so if it is having 3 set of connector, means you can connect the what? Connect the power cable of the BLDC motor to these points. So technically how we can consider from where we need to start the connection? Now you see it's written over there, this is M1. Okay, M1 represent motor 1. Similarly, it's represent motor 2. Over here it's represented motor 3 and over here it's represent motor 4. Okay, you have to follow that mark so that you can connect the right motor with the right connection. But now someone gonna ask, is it necessary that we have to follow these marks? Why don't we just connect the ESCs, because we are going to connect the wire properly? Is it necessary that we have to follow the mark? Yes, that is necessary. Why? Because the flight controller having some kind of layout. Okay, the point of flight controller I'm going to start right now. So on that time I'm going to represent that the layout of motor is very important. If you mess with the layout of the motor, or if you did some kind of mistake on the build, what will happen on that time? You can't imagine the drone could get crashed instantly, or it is very much possible someone got hurt. Okay, so motor layout has to be perfect, otherwise the drone is not gonna fly. Okay, that is very important that we have to maintain the motor layout. That is why I'm saying if the ESCs are separate, then it is okay, because you are going to connect as per the data chart or as per the point is written on the flight controller. But if you are using a stack like this is known as a stack. So if you are using stack like this, then what will happen? You are going to get some issue if you are not following these points. So I hope you understand about that thing. Now we have to move towards another point, that how to tell the ESC when it is going to rotate, and how the ESCs is going to be sync with each other. Is this ESC will provide brake on this motor? Yes, it's depend on the ESC's specification. You have to get it first. That if you are using Bell Hell ESC, means I'm talking about the stack one. Yes, stack is also having braking system. Why the stacking having braking system? See, because the stack is having one more thing. Just give me a second. Okay, now see what's happening over here. See, this is a Bell Hell ESC, means the firmware is present in the stack is Bell Hell. Okay, it means it's having all the features that Bell Hell is going to provide us, including braking, measuring back EMF, as well as in some ESCs, which are very smart, and technically speaking, the advanced ESCs can sense and get the data from the Hall effect sensor present in the BLDCs. Okay, so yes, it can give us a braking system, definitely. So let's talk about how we can define our flight controller. So what we have here, we have few things. That the one is BLDC motor, then we understand we need a ESC, and now we need one more thing, that is the flight controller. Before we are going to proceed, I need to tell you one thing about the ESC that is a confusing point for the beginners, not for the professionals because they know about it, but for the beginners. See, I'm talking about this cable, okay, which is coming out from the ESC. Let me zoom on the cable for you. There it is. See, if I'm talking about this cable is known as a servo cable. I already told you this is a servo cable. But remember one thing, do not try to give power to this cable. Means if you think that I should put a 5-volt power or 12-volt power in it, no, don't do that. Because this cable, the red wire you see over here, this red wire is going to give you a 5-volt power supply. This red wire is for the positive, and similarly, this black wire is for the negative. They both are output pins. Technically speaking, means they are output powers. They are going to give you output. If you want power, you can get it from there. Okay? Do not try to put power in it. ESC is not taking power from this point. But there is a but. What I'm talking about? This one. If I'm talking about this cable, the white one, or in most of the case, it will appear as yellow. In some ESCs, it will look white cable. In 90% ESCs, it will appear with yellow cable. So always remember, this is the signal cable. This is the signal cable. Means over here, you need to put the signal. This is the input part. This is the input part. You have to put the signal in this cable. Then the microcontroller which is present in the ESC is going to get the signal. It could be from the receiver of the remote controller, or it could be the flight controller that where you are going to put this cable. Remember that point. Without this, we cannot able to put signal in the ESCs, and it's not going to work. Okay, so there we go. That point I need to explain. It's done. Let's move forward towards the flight controller. There it is. Now we are going to talk about the flight controller. First, we have to understand what is a flight controller, how the flight controller works, and what kind of flight controller we have over here to build our projects. Let's understand it very clearly. In very simple language, flight controller are the brain of the drone. Okay, yes, the brain of the drone. So technically, if we are talking about what kind of flight controller we are going to talk about, technically we are going to talk about two flight controllers. One is open source, another there is a question with someone. In some ESCs there are only 2 wires, in some 3 wires. Yes, very good question, and sorry that I missed that point. In some ESCs there are 3 wires, in some ESCs there are 2 wires. Why? So if I'm talking about this ESC, this one, just change the slide. Yes, if I'm talking about this ESC, we have the red wire over here for the power supply, and the black wire over here, this one for the ground, and this one is for the signal. Which one? This one is for the signal. So in some case there are only 2 wires, means on that condition the red wire is not present over there, means the ESC is not going to give us any kind of power supply. Remember that. On that time, it is going to give us only ground and signal. Only ground and signal. That's it. No extra power is coming out from the ESC for you. I hope you get that point. But the question is that why, sir? To make it cheaper means it's kind of a cost cutting actually. No, actually it's not a kind of cost cutting, because if we are talking about those ESCs, they are actually costly. Okay, they are actually costly. Means if I'm talking about this one for you, just give me a second. Let me change the slide where my Bell Hell ESC. Bell Hell, there it is, Bell Hell. Okay, from the Bell Hell ESC, now you see if I zoom it for you. So if you see it very carefully, you saw there are just only two wires. Just only two wires. The white one, okay, this is the white one, and the black one. Okay, there is no power wire is given over there. Why? To make it compact, because you are already using PDB. Okay, you no need to use that. First point. Second point, it's depend on the flight controllers also. If I'm talking about a earlier flight controller, I'm going to show you the images. We have those. So the traditional and the old flight controller doesn't have any kind of power controlling board. On that time, we are going to put the power from ESC. That is okay. But now in modern days, all flight controller having their own power controlling boards. So they don't want the power from the ESCs. Okay, that is the biggest point we have to understand. So on that time, what happened? If they don't want any kind of power from ESCs, then why don't we just remove it from there? Because that is not going to use for that. So that's why they remove the PowerPoint, and while they are removing the PowerPoint from the ESCs, then what will happen? The size is going to be shorter for a little bit more. Okay, that is a nice question actually. Thank you. So let's go back to the point. So where it is? Where is my flight controller? There we go. So this is the flight controller, and in this flight controller we have to understand what kind of processing power and features we are going to understand. Technically, if I'm talking about the CPU present in the flight controller, is will consider as F1, F3, F4 and F7. Okay, so right now in these days, F1 and F2 is outdated right now. Okay, they are outdated. Why? Because they have very less flash memory, very less amount of sensors we can connect over there, less amount of stability due to lack of vital sensors in it. And the most important thing, we cannot put a bulky program in these flight controllers. But still they are in use. In which phase we are using? For creating toy drones, or if we want to create just a nano drone which is very small in size, we can use the F1 flight controller, F3 flight controller, which is very cheap and easy to available in open market. Okay, and if I'm talking about F4 and F7 flight controller, F4 and F7 is the one of the most powerful flight controller which we have right now, and that is available in open market that we can purchase easily. The thing is that it's having more serial ports. And what is serial port? We are going to discuss it about that. What are serial ports? And we can connect multiple sensors. We can put lots of instruction in it, and as well as due to the large flash memory, we can operate a small AI inside these things. Okay, means you connect with another microcontroller and put some instruction over there, and they are going to talk with each other, and as per the result, the flight controller is going to make it fly on their own. Means you no need to operate it from somewhere. That is the thing. So it's all depend upon size of the flight controller. Means what kind of flight controller you want to make the drone. It's 45 mm, 30 mm, 20 or 16 mm. technically these are all for the RC drones. Right now, the flight controller which I'm representing you, these are for the micro drones or for the nano drones. Okay. For the heavy drones, I'm going to represent it on the next slide to you. Okay. And similarly, there are few feature based, means if we are talking about a simple flight controller with having not a excessive kind of sensors and thing over there, so that is the first one. And if it is having a PDB and ESC inside over there, and if it is having a VTX inside over there, VTX means video transmitter and receiver present in this flight controller. What is the VTX? I'm going to represent on you. I have the VTX for you to represent it over there. Okay. And sir, you are telling about flight controller open source, like in kindly example. Okay, fine. Yes, definitely. I'm going to tell what is open source and what is open source and not open source over there. So just give me a second. We are going to move toward that slide. Okay. So these are the flight controllers which we have. Right now, the flight controller I'm representing to you, they are all open source. Now, what is open source? Open source means we can change the program, we can change the parameters, we can change the setting of these things. Not only a simple setting I'm talking about root setting of these flight controllers. Okay, you can change lots of things in it. You can put mission planning, you can put coordinate launching, means if the drone is in a certain location and if you put the drone at the top of the car and you move the car in a certain location, the drone knows that my location is correct, the drone is going to fly on its own. So that kind of thing you can build by the open source flight controller, which allow you to access the entire root program of it. Okay. Similarly, if I'm talking about how the flight controller works, so in a flight controller, there are multiple sensors put over there. What kind of sensor has to be present in a flight controller to get a stable flight? First, the sensor we have to get in it, which is barometer. Yes, the barometer help us to find out the altitude of the drone, which help us to maintain the self level of this drone. If we are making a drone and that drone has to maintain its height, it has to be by the barometer present over there. Similarly, there are some kind of magnetic sensors and there are some kind of GPS over there. So lots of thing inside it. But in most of the case, we put the GPS externally. Okay. And there are servos also involved. If we are making a airplane or a bicopter, remember, airplane means fixed wing drones and bicopter involved with servo also, because we are going to change the direction of the motor or we are going to change the rudder. Okay. If I am talking about the control points, what are the control points? This control point. Control point means the signal we are going to send from the remote control. That is the control point, means the receiver which we need to fix to the microcontroller. One more thing, in some cases, we can fix a AI also over there to control the drone. Means a person is not going to control it, a AI software is going to control the drone, means the instruction is going to give to the AI and then the flight controller act according to this. And when all the signal instruction is getting to the flight controller, means it's having all instruction and data, then it is going to tell to the motor what to do and how to do. Okay, means if you want to run, yes, at what RPM, that is the RPM you have to achieve to maintain the height and maintain the stability. But still there is one more thing is missing over here, that is ESC. It's always come between the flight controller and the motor. Remember that. Okay, so that is the point we have to understand. And the question is that, sir, thank you so much. Thank you so much. Now, this is the point, that what flight controller do we get from our nearest store or from the online, that which we can use to build. All right, just give me a second. Where is my pencil? There it is. So this is known as KK2 flight controller. KK2.0. KK2.0. It is 2.0. Okay, why this is KK 2.0? KK 2.0, 2.1. Okay, this is known as KK flight controller. Okay, I'm just a little bit confused about the KK 2.0 or KK 2.1 because it's all about the buttons. In KK 2.1, the button is red and there is some changement inside the firmware, but let's understand about this flight controller. This is the most traditional flight controller, KK. KK is the one of the most traditional flight controller used by beginners. Why? Because this is the most cheapest flight controller that you can buy right now. Fine, first point. Second point, if I'm talking about the stability, so the point is that no, the KK is not so stable, but yeah, it is going to give you a certain flight so that you can learn that how the drone works, how to build the drone. It's going to give you a certain information. But if you are seeking that position holding and altitude holding and the stability, so no, it's not going to give you that much amount of stability. Why? Because it don't have that much amount of sensor present in it. It's having gyroscope and accelerometer, but in this KK2, I think there is no barometer over there. And due to the lagging of barometer, the self level of this drone is not good. Okay, that is the first point. Second point, it doesn't have any kind of power controlling board. So that is why you have to put the power from the ESC. Yes, that part, that section is going to connect with the ESC. Means this section is going to give instruction for the motors. Okay, and this part is going to connect with the remote control. That part is for the remote control receiver. Okay, 3 cable of, yes, in this flight controller we have to use the 3 cable ESC. Good. So that is the point. And one more thing, in this flight controller we no need to put any kind of software because all software is pre-installed in it. You have to calibrate it by these switches. That's it. It's having a display over here. It's having a display. You no need to connect with computer because there is no port that you can connect with the computer. Okay, if you want to flash it, there is a different method to flash the drive, but otherwise you no need to connect it with any computer. You can just program the drone with these buttons. That's it. Okay, what you need to set, I'm going to explain it later because there are lots of stuff. You have to give the right PID setting. PID setting means post integral derivative setting. What is it? That is a vast topic. So in just short, I'm just telling you, PID means the response time of the drone. Okay, means if you are pulling the stick and at what speed and what response the drone is going to act, that is done by PID. Okay, the higher PID, the higher response, means it's going to quick and fast. The lower PID means the drone is going to be some laggy or some slow and work in a very quite slow motion. It's depend that how the drone is going to be response in which PID setting. That is the point. So in this flight controller PID setting very important. So yes, you have to be patient with that. Next one, which I'm talking about, that is APM. This is APM, widely used from students, from BTech. In most of the BTech college, they using APM. Why they using APM? Because there are lots of tutorial available in YouTube. There are lots of components available on APM. But now onwards, those people who are going to see this video or watching there right now this video, remember one thing: do not use APM anymore. If you are going to purchase APM, right now the APM is available on the market. That is the most worthless flight controller, in simple what I want to say, because it is totally garbage they are going to make, because it is not made by the original company right now. This is a totally duplicate copy. All the sensors is gonna work in an odd way. They are not producing the proper data. The flight is not stable. And the most important thing, if you want to calibrate this flight controller, you're gonna feel you are in a mess right now. Okay, so if you having a APM with a older version, or someone purchased APM in some 2019 or 20, that gonna work fine. Okay, but right now in 2022 or 23, if you are going to purchase that APM, don't do that. Don't do that. Okay, so but that was a time when the APM ruled the market. That's why I put it over there for you. Now we are going to talk about the two kings of flight controller. They are ruling in the market, and they are one of the most powerful flight controller. And one is a open source, another is not an open source flight controller. So who I'm going to talk about first? So I'm going to talk about first about the DJI NASA series. Okay, so DJI is a well-known brand in drone. Everyone know about the DJI. Okay, if someone asks, sir, where it is DJI, there it is. This is a DJI flight controller. DJI is one of the leading brand in drones. DJI provide their different category of flight controller: DJI M-Lite, DJI V2, and they have different type of flight controllers available in the market. So right now, if I'm talking about DJI flight controllers, they are the most reliable flight controller that you can buy, because these flight controllers are built by a specific company. DJI, yes, DJI Phantom drones, they build the Phantom drones. They have Mavic, they have Air, they have Avatar, they have lots of drones available over there. But they are selling their flight controller also. If you want to make your own drone, welcome, you can build with the DJI flight controller. Okay, so this is the one of the best flight controller is available in market. But remember, this is not a open source. If you think that let me connect a telemetry with it, or if I want to connect some kind of different microcontroller so that I can give some instruction over it, costly too. Drones are costly. DJI drones are costly. The flight controller is not costly. Okay, this flight controller, if I'm talking about DJI M-Lite, okay, M-Lite means multi-rotor light. It could be cost around 7 to 8,000 rupees. That's it. Okay, and one more thing: the size of the this flight controller is just about a matchbox. Okay, I think it's almost 15 minutes I'm having, so I just want to switch the camera and show you the how these things look like in real and practical implementation, and how these things are connecting with each other. So, and in final, there is the another king, which is Pixhawk. Okay, another king, that is the Pixhawk. They are using to build a big drone. Okay, in DJI NASA, you can go for hexacopter. 6 motor you can connect. As you see, this is from motor 1 to motor 6. But if I'm talking about Pixhawk, you can go for the octacopter also. Okay, means you can go for 8 motors also. That's the point. Right now, we have to understand one more thing. Pixhawk is open source flight controller. You can connect multiple sensors with it. Means if you want that, if you want to connect ultrasonic sensor, you can go for it. Means if someone is coming towards the drone automatically go back, because due to the ultrasonic sensor sensing that someone is coming towards the drone. Okay, it maintain its height. You put some laser guiding system over there. If you are, if you want to get the data from the drone directly to you, you can go for the telemetry. You can connect telemetry system. You can connect VTX system over there. You can connect multiple things with Pixhawk. That is why the Pixhawk is one of the, sir, if we, what is it? If you want to instruction, where it is, information deleted. I think someone asked some question. What is it? It's gone. Okay. So that is the Pixhawk. Okay. So right now I am going to switch the camera and show you how these things are going to appear. And one more thing, this is the remote control system I need to show you. Okay. Because there are lots of things in remote that we have to understand. All right. So, sir, what about the vector flight controller? Can we use that Arduino? No. Okay. The point is that we can go for that, but Arduino Nano or Arduino Uno and Mega is having a big problem. The clocking cycle. Okay. The problem is that the Arduino Nano and the Arduino which we are using is a clone. The Atmega 328 IC which we are using, that's also a clone, not produced by the original company. That is a cheap copy of China. Then what will happen? The clocking of that processor is very low. What's happening on that time? The response of the drone is going to be very laggy. Means in a drone flight controller, the program has to be refreshed in fraction of seconds. Okay, there should not be any kind of lagging over there. So right now, if I'm talking about, I think battery is gone. What? No, having the battery. All right. So what's happening over there? We want a fast flight controller which can think in a fraction of second. On that time, we cannot do, or we cannot put a flight controller which can think or which can gonna lag at the time when the drone is need to stable itself. So it is possible that we can build with a drone by Arduino Nano and Arduino Uno, even though someone using RPi also. But the problem is that the stability of the drone, because we need to put barometer, accelerometer, magnetometer, and as well as some kind of meter that help us to put the drone in a certain level so that the drone can get the information from somewhere that yes, I am in a this position. So you have to put the GPS also over there. So it's going to complicate and bulky thing over there. So I don't recommend that you go for Arduino Nano or Uno, but you can build or you can try for it. So if we want to instruct a drone with AI, when we need to work to fast and find the data according to the customer in the drone. Yes, definitely. It has to be very fast. It has to be very fast. Okay, so let me switch the camera for you. I need to stop the screen share. And where is my stand? There is the stand. And let me put my phone over here for you. And there we go. So just give me a second. I need to switch the camera. There we go. All right. I hope everyone can able to see. Right now, we are going to start learning about the entire concept of the drone and how these things are fixed and bind with each other. Let me focus over here first. There it is. So right now what it is, this is the remote receiver. This is the remote receiver. What's happening here? As you see, there are two different antennas connect over here. Okay, I just fixed the antenna at the bottom of the plate. So what's happening here? This is the remote receiver. In the remote receiver that I already represented you, just give me a second. I need to bring the remote control for you so that I can represent the remote also. All right, back. So what we have, just give me a second. There it is. So I hope everyone can able to see. All right, there we go. So the remote control, you are saying this is the one of the most advanced remote that we have right now. What's happening? Okay. Okay. So what's happening here? I just turn on the remote and the remote is emitting a high blast of radio signals, and that radio signal is creating a mess with my signal. Sir, name and specification. This remote is FlySky FSI6S. It's having a touch screen, and the thing is that if I'm blasting the remote, actually, if I'm trying to turn on the remote, now you see the entire camera and everything has to be laggy right now. I need to just turn off the remote. Everything has been stopped. Let me turn off the remote. Yes. So when I'm trying to turn on the thing happening, it's going to blast a huge amount of radio waves. This is a very powerful and strong remote. Okay. So what it's gonna do? This is the throttle. This is the throttle body, and this is the rudder or yaw. Okay, and this is elevator, and this. So I know this is a part of the movement. I'm gonna explain in next session. Which flight controller is cost effective? Network issue, please consider. Yes, I understand. Due to the remote, that is the network issue is starting up. So I cannot turn on the remote. Okay. So in starting, we need to discuss about Node MCU and Arduino board, but we are not using all bulb and module programming device. Tomorrow we are going to talk about the Node MCU and different bulb thing. Okay, that means tomorrow we have the what is yaw and pitch. That is a movement of the drone. Means yaw means the if I'm talking about this drone, if the drone, I hope you can see the drone. Okay, if the drone is going to rotate like this is known as yaw. Okay, so I saw you the remote, and then we have to understand few more points. Let's see what's happening here. Just give me a second so that I can focus it over there. Yes. So this is the receiver. The signal is going to get from the remote, that signal is going to send from these cables. Okay, these cables are going to send these signals to where? To the flight controller. Now you see the flight controller is over here. Okay, this is the flight controller. The NASA flight controller is placed over there. At the top of the flight controller, we have a FPV camera setup also. Okay, means the drone can see, and that data we are going to receive from the drone directly, and we can broadcast that data from this. That also a point. Similarly, I told you the power board. As you see over here, this black box, this is the power board for this NASA M-Lite. Okay, it means this NASA do not want any kind of power from the ESCs. Similarly, if I'm talking about that part, this part is for the remote control, means that part is for the remote control, and that part is for the motors. Okay, that part is for the motors. Fine. Means right now, if I'm talking about this drone, this is having a first, technically this is the first motor, second motor, third motor, and fourth motor. This is the layout of the motors. So on that condition, now you see, if I able to focus in it, the marking is present over there. Okay, M1, M2, M3 is been written over there, so that we can put the motors according to the instruction. That is the important point we have to follow. And then this is the programming point, programming lead we have to fix over here. And that lead is going to connect over here, that part. Okay, it is going to tell by the user manual and instruction to you that you have to put the LED point over here. This is known as the LED. If I power up the drone, this is the PDB. What is PDB? Let me show you the PDB. That board over here, this is the PDB board. Okay, at the bottom of the drone, this is PDB. I hope you can see. Let me focus over there. The bottom plate, this plate is the PDB plate. This is distributing to the ESCs. As you see, it is going to send power towards different ESCs. This is a first connection of ESC. This is a first ESC connection. As you see over here, sorry, let me zoom out a little bit. Okay, that is a first connection. Similarly, all the different ESCs are connected in different parts. Now you see, okay, all the different connections are gonna fixed from here. That is why this board is known as power distribution board. And by the help of power distribution board, this is the battery lead we have over here. This is the battery lead. And what I'm gonna do, I'm gonna just boot the drone like this. When I'm gonna boot the drone, now you see the drone has been triggered. It has been activated right now. Okay. So what happened over here? Just give me a second. I hope you can able to hear me. I think all signal has been lost. What? Okay. Video connection has been lost. Video stopped. Yes, due to the drone, means the drone having a large radio blasting, and the radio communication setup create a mess with the connection with the phone Wi-Fi to the laptop. That's happening with us. So if we are trying to which hardware component responsible for providing cloning attack, how it is addressing. Okay, hardware, actually it's all about magnetic fields I'm talking about. Now I hope now you can see me. Okay, now it is visible to us. Okay, yeah. So what's happening when I'm trying to put the drone or the remote control in active? So on that time, the EMF blast is going to produce, and due to the EMF blast, all signals is going to jam on that time for a few seconds. Then I have to turn it off. Then everything is going to be in stable mode. So that is the point we have to understand. If you are using using a powerful drone setup, you have to use a high power remote control setup also. Means if I'm talking about this remote, it can be work up to 3 to 5 kilometers. Okay, so just imagine what kind of power this remote it's having in it. So that is the point. So thank you for this session, and tomorrow we are going to give a quick revision, and I'm going to give you one more thing, that how to calibrate. Can I see the recording of this session? I think you have to just put a message over there. Thank you so much. Thank you so much, everyone. And if anyone want to get the recording, just send the mail to the team. They are going to tell you. Thank you so much. I'm just trying to give you lots of information so that you can build your drone on their own. And I wish you get some good information from our side, and thank you so much. And tomorrow is the last session. Thank you so much. Thank you so much. And tomorrow is the last session. And thank you so much for the lovely comments, everyone. And tomorrow is the last session. We are going to talk about the IoT that I already promised to you, that I'm going to give you a quick revision over there, as well as we are going to do one more thing. We are going to create the system for multiple devices that we can control. And we are going to tell one more thing, that how you can calibrate these drones, means how to set up the program, what software we need. And all right, thank you so much. I think tomorrow you are going to get your all PPTs, because our team prepared all the study material for you. And tomorrow they are going to send all the PPTs and all programming, even though a part of programming is also going to provide for you, so that you can build your own IoT system. We need, I think, minimum cost of assembling a drone. A minimum cost of assembling drone, it could be around 15 to 20,000. Okay, you can build a good drone. Okay, in 15 to 20,000, you can build a very good drone. All right, thank you so much, and see you tomorrow. Take care, and thank you for a lovely session. Thank you all.